ones that should be competing with one another. But just as often, it's important for the government to try to promote collaboration or collusion between people who need to cooperate with one another and who, in the absence of cooperation, would not achieve beneficial social goals, right? And that's exactly what we're going to try to talk about today. Public projects which require individuals to cooperate in order for them to succeed. Basically because they have diffuse benefits or costs which are spread out over society, and therefore voluntary initiative is unlikely to be able to achieve the goal because individuals will be unwilling to bear the diffusely spread out costs in order to achieve the social benefit associated. So we'll start by talking about Cournot's model of collaboration, which will link up very closely with what we've been studying in the last couple of classes, and which is sort of the simplest model of this type of a situation, and related to Cournot competition, and from that derive a corollary to Cournot's theorem, but which is going to be much more pessimistic, which is going to be that as the number of people gets large, you won't be able to achieve anything in a collaborative environment. We'll then talk about the relationship of these ideas to public goods and bads, and then talk about why private solutions to these problems usually won't work, as well as how coercion is in practice and should be used to deal with these types of problems. In particular, we'll focus on the case of assembling complementary goods as is done in land assembly or eminent domain. And then we'll talk about how, once we're going to use coercion, we as a society can make a decisions about how to use the coercion. And those social choices will be the thing we end on, and then I'll give a really brief wrap-up of the course. Okay, so Cournot was a pretty smart guy. He came up with a monopoly model. He came up with a competition model that we talked about. And he also came up with this very important model of what he called collaboration, or in French, concours. So in this model, there's n firms, but rather than producing perfectly substitutable goods, they produce perfectly complementary goods. So that means that consumers need to have all of the goods in order to get any utility. And therefore, the consumer's demand depends not on just like the price for any individual good, but on the sum of all the prices, right? Because they have to purchase all the goods in order for it to be worth it for them to purchase any of them. So the quantity that they purchase is a decreasing function of capital P, which is the sum of all the individual little PIs, which are the prices charged for each of the goods. And for simplicity, again, we're going to assume that each firm has a constant marginal cost, CI. Profits are then PI minus CI times the quantity, which depends on the sum of everyone's prices, right? Another way to rewrite that is that each firm's profit is its markup times the quantity, which depends, this should be a plus here, which depends on the markup plus the cost. The total markup of all the firms plus the total of all firms' costs. Right? Because the total price, each individual price is just the cost plus the markup. So the total price is just the sum of all the markups plus the sum of all the costs. Sorry, again, it should be a plus. So as usual, all the capital letters are just the sums over all firms of the small letters. And notice that this is very similar to something else that we were looking at a couple of lectures ago. And I don't think Andy's here, is he? Does anyone want to try to relate this thing that the firm's trying to maximize to something else that we discussed a few lectures ago? Any ideas? Well, so notice that what everyone is doing in this case is they're all taking the prices of everyone else's given. So they're each going to try to maximize their profits, taking as given the prices charged by all the other firms. Right? And the quantity that they sell depends on the sum of all the prices. And profits are determined by the product of the price that they charge, price or markup that they charge, and quantity. Okay, so in some sense that's exactly the same as the Cornell model we were talking about before, right? Because in the Cornell model, everyone takes the quantities of all of their firms as given. The price that they get depends on the sum of all the quantities. And the profits that they make are the product of those quantities and the price. Right? And so if you just switch the word markup or price for the word quantity, this is exactly the same as the Cornell model. Right? And so this model is exactly what's called dual to, or equivalent to, the Cornell model of competition. Except that the relevant choices are made about the prices rather than about the quantities. Does that make sense? Okay, so then what we can do is any result that we got in the Cornell model, we can apply here, just interchanging prices and markup, prices or markups for quantities. So, however, notice that in the Cornell model we would say things like, well, the quantities get small. Here we'd have to say the markups get small, or that the price goes to what's efficient. Here, in other words, the firms make no profits. Here, the quantities are going to have to go to zero in those same circumstances. So every result that we got there is going to be reversed here. So as the number of firms grow, rather than getting lower and lower prices, we're going to have to get higher and higher prices and lower quantities. This is sometimes called the double marginalization problem. The basic problem is that each firm, when it raises its price, reduces the quantity that all the other firms in the industry sell, not just the amount that it sells, right? Because no one wants to buy the left shoe if they can't purchase the right shoe, right? So when the price of the right shoe goes up, the quantity purchased of the left shoe goes down. And that means that each firm sort of piles its own markup on top of the cost of producing the good. And because they don't take into account the harm that this has on other firms, they're each sort of scrambling for their little part of the pie, even though they're reducing the overall size. So as each tries to get a piece of the total profits and crowd the other people out of getting a piece of the profits, they're going to drive down the profits made by all the other firms. So actually, if all the firms were to merge together, they would actually lower prices, not raise them. Right? Because they would then internalize the fact that if they raise their price, that harms another person who's producing a complementary good. So what this means is that we should have very different policy approaches towards vertical mergers. What's a vertical merger? Well, if like a coal company produces coal that they then sell to a steel company, which then turns it into steel to sell to consumers, mergers between the coal company and the steel company are going to be potentially beneficial, even if there are no efficiencies. Whereas a merger between two competing companies will typically be harmful, as we discussed in the last lecture. Another example would be a patent pool. So if there are a bunch of different complementary technologies, like, the technology to make a case for the cell phone, and a technology to make the cell phone, or the technology to make a SIM card for the cell phone, and the technology for the device, a merger between those companies will actually lead to lower prices because they won't each be trying to grab a bigger chunk of the total profits driving up the total value, right? Okay. So vertical mergers, mergers between complementary goods, give exactly the opposite result of mergers between substitutable goods. And Nick, what do you think the reverse of Cournot's theorem in this context would be?
The prices will go down as there's more firms.
Well, that was Cournot's theorem, right? But here, everything is exactly reversed from Cournot's theorem, right?
And then the prices will go up.
Yeah, so Cournot said that as the number gets very large, we get towards perfect efficiency. What do you think, what's the opposite of that here? What would be the exact opposite result?
Are you saying that with vertical mergers, you're saying?
No, so Cournot's theorem was about as the number of competing firms gets large, prices go down to cost, and we get an efficient quantity.
Yeah.
What will happen as the number of complementary firms gets large?
Oh, then prices will go up because then there's so much. They'll go up because then they're all competing. Like you just said up
Yeah.
here with more firms.
And what would be the really extreme outcome? So if the extreme
There'll be
outcome
nothing produced.
nothing produced.
Yeah.
Yeah, the whole market shuts down. So that's called Bergstrom's. So each, as the number of firms goes large, just as the markup went to zero before, now the quantity produced is going to go to zero, right? So each firm's markup individually becomes small. Collectively, there's so many firms producing so many markups that the price goes to infinity, or to the point where there's no demand. And so we just get these layers and layers of monopoly. So this is sometimes called Bergstrom's corollary to Cournot's theorem. It's also called the tragedy of the commons, or the collective action problem. And it's sort of the key thing we'll focus on today. Throughout the course we talked about this idea that if people only have a diffuse interest in something, they'll tend to fail to achieve their collective goals. And that's exactly what's going on here. If there's a bunch of different people, all of whom have an interest in a low price, but each of whom individually would like to grab a bigger part for themselves, everyone will end up eating alive the industry and eventually destroying it. Yeah, there you go.
This is kind of a dumb question, but when you say N firms, you mean that there's N complements?
And perfectly complementary.
So to get one, you have to get all of them.
Yes, exactly. So as they become more and more, as it becomes more fragmented into more and more complementary pieces, the market falls apart. Okay, so let's consider a very similar but even more famous problem, which is basically the one we saw in problem set 3. So imagine you can make a costly contribution to a charity in an amount AI, right? And each person gets some value, VI, which depends only on the total contribution that everyone makes, not on the particular contribution that they make. And let's assume that everybody prefers there to be more contributions to the charity. So then each person's individual value is VI of capital A minus AI, whereas the value to society is capital V of A, which is the sum of all the individual values. So any individual making a contribution brings a total social value, capital V prime, but brings a value to each individual of only VI prime, right? So one example of this would be if everyone was symmetric, then the social optimum would be that V prime over N, the private optimum